Today we're here to highlight a Python app that includes a shapefile, a Scatter-mapbox, and a bar chart with Dash, Plotly, and Pandas. Now, this app was part of the Colombian Wildfire community project on charming data, and it was built by Laura, an electronics engineer working in the semiconductor industry who is passionate about data. Hi, Laura. How are you? Thank you for joining me.
Hi Adam, hi everyone. Happy to be here.
So, Laura, what motivated you to join this project and build this awesome app?
Oh well, all the community projects from the Charming Data community are made by multiple parts, and everyone can participate accordingly with their background and resources. With regard to this March project, we have two parts. The first part was related to analyzing and build an app to review the historical data related to the wildfires in Colombia. Whereas the second part was related to rebuild the NASA app to monitor the wildfire. So actually this second part was more something professional. Well, I focused mainly on the first part because the study of the historical data, because I have no prior experience with the maps and geographical data, but I found them very interesting. Actually, the maps are very insightful visualization, and so given that I have no prior experience, I decided to set my personal goal and develop my version of the first part, the first app, in order to become more familiar with maps and geodata. And so let's say that my goal in this case was to learn about how to manipulate and do operation with geospatial data. Why this is important for me? Because actually, as I said, I have no background on that, but working on this real case, working on a real situation with the real data, helped me to add one tool more in my box. Okay,
Right.
and I this enabled me to become a little bit more familiar with all the problems involving spatial data, where there is a special relationship between items, and so I can face a new problem with the new tools, and it could be actually very important for me. And so in this case, during this journey, I had a chance to explore new file formats, approaching the usage of new Python packages, new for me, and the visualization of the map, reading the documentation, and try to implement and working with geospatial data. And I come actually to the implementation of my first app involving maps. So I think that I meet the goal.
Really cool. And it looks like your personal goal paid off because you built a pretty cool app with the map, the bar chart, and some explanations. So why don't we go into it? I'd love for the world to see the type of app that you made. Would you like to demo it for us?
Oh, sure, sure. Okay, so let me show the main feature of this app. So first of all, this a single page app with tabs. We have two tabs. The first tabs actually include the visualization. So we have the map and linked plot in order to show the trends across the time for the wildfire in Colombia. Whereas the second tabs is a very preliminary implementation of a kind of user guide with some detail about the features that I implement in the app, and further suggestion about how to implement the code and manipulate the data. But anyway, let me jump back to the first tab. So the wildfire report. We have okay. This is the map, and the user can select a different kind of background. Okay, maybe this is a little bit dark. There is a whiteboard. My favorite
Nice.
one is the OpenStreetMap. Everything is made in Python and using all the components available in Plotly. This is a Scatter-mapbox plot.
Uh-huh.
And here we have a series of control in order to enable different features. So manipulate the map. For example, here I can switch into the animation.
And Laura, is this the background of the map and the style? OpenStreetMap, is this free or you're using your own Mapbox token?
Oh yeah, good question. Everything that I'm using here is free. So all the background, there are some background if you look into the documentation that require to have some token or they are from paid services. But in this case, everything I implemented here is fully open, is free. So my GitHub repo is open, so everyone can replicate without any requirements of token or registration to some services. Okay. Yeah, then so I added the animation, different background. Well, one more item is that the main purpose for me was to learn. So I started by using a full data set provided by one member of the community that was the ones that proposed this project. So thank you, Olger. Okay, but given that my purpose, as I said, was to learn, I decided to reduce the size of data set in order to avoid to long computation time to plot the maps and so on. So yeah, let me say that the original data set is data from the beginning, from 2000 to today, but I decided to focus only on a limited number of years, recent data, and in addition, the full project involves the entire Colombia, the entire state. But in my case, I decide just to focus. I select some parks, big parks of a territory that is the Orinoco territory, and so I filter the data and make everything easier.
And where can we see the
Yeah.
parks there if you
Oh,
click on the
sure.
radio button?
Yeah, let me, for example, let's reduce the data. That is easier in this case, but yeah. Okay, so with this feature, you can show directly the border, so we can also see, I overlap the data from the wildfire, so the points inside the border, so we can actually see the points inside. In addition, well, the original data set has all the wildfire, not just all the parts of Colombia, but also all the wildfire occurring across the time. And one of the operation was actually to understand if these points occur in this, if this wildfire occur in the parks. Then together with this, let me switch back, maybe remove the parks. Okay. I also added the capability to filter the data, so we can filter all the years or just select data from a specific year, but also if we can also select one specific park. One more, here below, I try to create some interactive app and connect all together all the components. For example, in addition to the map, I also plot a scatter plot that show across the time. Here I plot the year and the months across the time, what is the trend of the plots. And actually we can see that there are some kind of trend, okay, such kind of, let me say, seasonality in the data. This helps to see the data that we show here in the map from a different standpoint and find, for example, some insights. I decided that at the end to add one more feature because, okay, I have the information about the wildfire and when they occur in the time, but I think that the user can have, for example, more data on demand. Let me maybe switch back to all the parks. And by moving on the map, we can have some information through the tooltip, but I decided to experience one more feature that is available with the Plotly components is on the maps, is the click. So I click the data and actually I can show more information from the original data set from a selected points. For example, together with the date when this wildfire occur, I also decide to enrich the data set by adding further information like the location, like the town, and but also information about the weather condition. So to add further more information, further more details, and these were not present in the original data set, and so I decided to join this data together with some other data coming from the web, coming from some specific free, everything is free, as I said, API, and that are available. So I merge and create a big data set with many more information.
That's really cool, especially that because you merge information that is also relevant to fires, right? Wind can help spread a fire, temperature, rain or not rain, all that kind of information you can get from that API. Do you explain that somewhere, right, on how to do that?
Oh, yeah. Actually, this also enable further improvements of the app because, okay, now here I plot only the trend of the wildfire, but by adding further more works, we can also, for example, study the evolution of the temperature or
Right.
the wind across the time. Anyway, with regard to the usage of this API, here in the user guide, I added some information. For example, here is how I call this API is from openmeteo.com. This is the you can no need to be
Nice.
to register, and there are Python. I use the request package, and for example, in this case, this call include the parameters. So you pass the latitude and the longitude of the points of interest. For example, your town, okay,
Yeah.
and if you are interested in historical data, you can select a certain start date to the end date, and also you can specify which kind of information you want to collect. In this case, I would like to collect the maximum temperature or the average temperature, the information about the weather at that specific daily, okay, and for example the rain. But if you explore the documentation, you will find that there are a lot of parameters, and you can get a lot of information about the weather in a specific location in a specific time, so you can do then your study about the trending and
Right.
learn a lot about what's going on around you. I think that it's, for me, it's a very very interesting.
Yeah.
Whereas
It's
sorry.
I mean, it's fascinating. That was the first part, right, of collecting the data from that API. Really, thank you for that, because that wasn't originally part of the project, but it's you're enriching the data can really help people not only understand how to connect to APIs, but how to further develop the app.
Yeah, and this is also to remark that I decided to add this further information because we have a topic for the project, but everything is free, so everyone can add, can try to be creative and make the app more interactive and
Right.
more insightful. And this is my extra contribution to this project. But we had also, together with the weather, we had also the location, because the initial data set has just the latitude and the longitude, but actually I wonder, oh, but I have no idea of where this point is located in Colombia. So I discovered that there are some packages that help you, Python packages that help you to reverse the geolocation information. And for example, from a latitude and longitude, you can get some let's say the address, and I use that to add this further inform. For example, here I extracted the state and the town when this wildfire occur. So yeah,
Wow.
something more.
Nice. Now, so thank you for the app demo. I just want to say that one of my favorite parts when you first showed me this app, when I saw it on the Charming Data project space, it's how you limited the wildfires to the national park reservations. I'm sure there was a lot of data cleaning to achieve that, and slicing. Can you please show us what that process looked like?
Oh yeah, sure. Before coming to the implementation of the app, I needed to manipulate the data because, as I said, I need to filter and simplify to avoid too long computation time. So, if possible, I would like maybe to share a notebook that I use to prepare the data. Let me share it. Okay, I started from the initial data set. I just keep a certain range of years, so I start to reduce. Then I decide to aggregate the data daily, and I also tile the data in order to aggregate the data over a range of 1 kilometer by 1 kilometer by using this very rough approximation. So, as I said, is an approximation. I know is not exactly, because I'm not considering any angle, any elevation. And this helped me to aggregate the data and reduce the size of the data set. Then the most important step for me probably was to understand which points occur in the parks of interest. First
Right.
of all, I select 3 parks, so I filter out all the other Colombian parks, and I keep here. Okay, and I keep just the ones that are from this territory. And I just after analyzing the data, I realize which were the biggest one, and I keep just 3 of them. Okay. Then I made the further simplification of the points. So I consider, given that the MODIS data coming from the NESA provide information about how what is the confidence of a fire detection, I just keep the fire detected with very high confidence. Okay.
What a high
And
confidence for you was what, like over 79% or over how much?
yeah, I decided to keep everything is higher than 80,
Okay.
70, 79. Okay, I
Yeah.
binned the data first because I read some documentation about this wildfire detection and how the NASA data works and which are the
Yeah.
meaning of the feature. And I found that actually what is high confidence is everything is higher than 80, so I decide to align
Okay.
to that.
Okay.
So actually, I start from a very big data set, and after many transformation, I reduce a lot the size. But then there is the last step, probably the most important for me, that helped me to learn a lot, was to understand actually which point, which wildfire occur in these. In the selected parks, and it seems something okay, easy operation. Well, not for me, given that I was not familiar before,
Yeah.
because I needed to do such kind of intersection operation between the points, so the wildfire and
Yeah.
the geometry of the parks. And by to do that, I use Geopandas.
Okay.
Geopandas is the extension, let me say, extension of the regular pandas package that is very helpful to manipulate geospatial data. Studying the documentation, I found that, okay, I needed first of all to convert the latitude and longitude from the original dataset to a geometry. In that case, I need to define a point. And with this operation here, that is using the Shapely package, I create from the latitude and longitude the points. Then when I have the points, by using the GeoPandas operation, after reading the documentation, I implement this intersection operation. Okay, so I found actually which point belongs occur in the parks. Okay,
Okay.
and after that, I got my final data set, and
Nice.
then I save it. Okay, let me check. Is a cross check to see. You can see that actually this is
Nice.
exactly what I reported in the app. So actually, my join operation and my intersection operation were successfully no, because yeah,
Nice.
I needed to
So,
verify. And after that, my data set was ready to implement and to be used in the app.
and now because you learned how to um, limit the wildfire points only within the park, you can also do that for each and every park. So you say, if I want the park on the
Oh,
right in blue, I can only limit to that park, right?
Oh, absolutely, yes. It's just a matter to redo the operation. You can, for example, you can keep all the parks in the entire Colombia area, and yeah, you can do exactly this join operation and this intersection operation and got the same result. Obviously, when you work with a big data set, you need to take into account your resources, and that could be time consuming. Depends on your
Yeah.
laptop, but anyway, yeah, you can extend. My case is just a showcase, is an
Good
example,
example.
but you can apply and you can extend to all shapes.
Yeah.
But
Yeah.
not just to geographical data, but everything involving spatial relationship you can do.
Right. Right. Really cool. Thank you so much, Laura, for
Welcome.
participating in the project, for submitting it, for talking about it. This was a great learning opportunity for me as well, because I don't have a lot of experience working with polygons. It's cool to see how you did it, and you limited not only built the shapes, but you limited the dots, in this case wildfires, into a specific area. So I really appreciate you coming here and showing it to us. As a reminder for everybody watching, we will add the project link under the video. We will add the app, Laura's GitHub repo, and anything else, Laura, that you want. If you want to add your LinkedIn profile, anything else, we'll add into the YouTube description video. And as a reminder, also, we just started our April project for the thank you, Laura, for the screen there. Response reporting app project. It's a pretty cool one. We have about 10 participants to help VOST Europe with a reporting platform. So join us. It's free. It's open to everyone, and the link is under the video. Laura, any last remarks before we close out?
Oh, well, I have already started to think about the new project, but anyway, if everyone is interested in work a little bit more on my March app and maybe create some extension or working maybe with the weather and add some more capability and features, feel free to contact me. I'm always open to share my learning and learn also from the other people. Absolutely.
Cool. Now, Laura, how should they contact you? Directly on GitHub or email or LinkedIn? What's the best way?
Oh, well, probably LinkedIn is the best way.
Okay,
Absolutely,
cool.
Yes. Yeah.
Great. So we'll add that onto the video. All right. Thank you, everybody. Bye-bye. Laura, have a good day.
Bye. Thank you. Bye, Adam.